Good morning and welcome to Module 9, which is Lesson 1, the causes of weather. All right, so the focus question today is how does heat drive weather? So, heat is just a transfer of thermal energy and it goes from something warmer to something colder. So, like we had mentioned before, if you're holding an ice cube, for example, your hand is warmer, so the heat will go from your hand to the ice cube, which causes it to melt. And then that's also what causes your hand to get cold. All right. So if we look at what meteorology is basically just a study of weather and phenomena that occurs in weather. So that would be like unique things like tornadoes, hurricanes, all the way up to just standard cold front, warm front, standard weather. So what the difference between weather and climate? That's something important to remember. So weather is day to day. So what's happening today, what's happening tomorrow. Climate is long term. So, what happens over the course of a year? What is typical for Reading? So, typically we have hot, dry summers, cool, wet winters. So that might not be what the weather is. The weather might be different this year, this day, but climate in general, that's what it would be. Is just year long, something that occurs over a long period of time, an average. Whereas weather is just day to day. All right. So the reason that we have differences in temperature on Earth is because the Earth is tilted and the Earth is spinning. So because it's tilted, we have a greater concentration of heat in one hemisphere, like the northern hemisphere, for example, in the summer, and less heat in the winter in the southern hemisphere. So, and then vice versa. And so the tilt is what creates the seasons. And then, of course, the Earth spins, so we have day and night, and that also creates unequal heating on the Earth. And that unequal heating causes air masses to move around, and that's what ultimately creates weather and climate. All right, so if we take a look at this, I mentioned that the Earth's heat is unequal. And so the Earth is tilted here, and it's tilted at 23.5 degrees. And so this, looking at this, this would be winter in the Northern Hemisphere where we are. And the reason I know that is here's the sun's rays. And notice the length of rays here. So these are short. It's traveling the shortest distance. It's getting the most intense sunlight. This is traveling through more atmosphere, so it's at a greater angle. So there's more atmosphere to travel through, so therefore less intense radiation. And so this is the northern hemisphere. So we are tilted away from the sun, which would be over here. And so this would be our winter because we have less intense sun. And then this would be the southern hemisphere's summer. And if it was tilted the other way, so let's say that the sun is over here instead. So then that in that case, the northern hemisphere would be in summer, and the southern hemisphere tilted away would be in winter. And so that creates that unequal heating on Earth. All right, so that constant motion of air is what creates thermal differences around the Earth. So the Earth is spinning, the Earth is tilted. That air wants to circulate and wants to move. Heat always goes from something hotter to something colder. Um, and so that creates wind and that creates air movement is that constant regulation of thermal energy on Earth. And that's where weather comes from. And so that regulation of temperatures, regulation of density, is what creates wind and air movement and ultimately storms and everything else. All right, so there's a couple things to know for weather, and one would be an air mass. So an air mass is just equal temperature, equal density, equal pressure, equal something. So an air mass is just a large volume of air that has equal something. So like I said, it could be temperature, it could be humidity, it could be pressure, just some type of characteristic. And it usually comes from a source. So we have in the tropics, we have warm air generally, and in the polar regions, we have cold air generally. So that would be our source region. Where did it come from? And then, of course, because the Earth is spinning, it's going to want to move to different regions. One, because of density, but also because the Earth is spinning under it. All right. So if it comes from ocean, so if it starts over the water, it's generally going to be humid air because there's evaporation occurring. And so we call that maritime air. And there's a couple different types. There's maritime tropical and maritime polar. So tropical, as you would imagine, it comes from the tropics. So it's going to be warm and humid. Air that's maritime polar is going to be humid and cold. And then we've got our continental airs, continental tropical. So you can see in this last bullet, continental tropical air, continent means dry. So if it comes from the continent, it's generally not going to carry a lot of moisture. So we tend to see that that's dry air compared to the ocean. So continental tropical would be warm, dry air. If it's continental polar, it's going to be cold, dry air. All right. So just remember that maritime comes from the ocean. And so it's going to be humid, moist air. Continental is going to be coming from a continent. So it's going to be dry. Tropical means warm and polar means cold. So knowing those terms, you know all the different air masses. If you were to see them, you would be able to tell if they were moist air masses, dry air masses, cold, warm, just simply based on the name. All right, so here's our different types of air masses. You do need to know these. And so we've got Arctic, continental polar. So just looking at that name, continental dry, polar cold. Continental tropical, that's dry, warm. Maritime polar, cold, wet. And then maritime tropical, warm, wet. And then there's these designations. So Arctic on a weather map, Arctic would be A, continental polar is CP, continental tropical is CT, maritime polar is MP, maritime tropical is MT. And then this shows where it comes from. So remember the source region is where it originated from. So maritime polar, if we just think about that, it's going to come from the poles over the ocean. So you can see North Pacific, North Atlantic. Maritime tropical, that is going to come from warm water. So that would be the Gulf of Mexico, Caribbean Sea, so anywhere along the equator generally. And then remember this, I mentioned that it's going to be, if it's maritime, it's going to be moist. So you can see these are both humid. Maritime polar, even though it's cold, it's humid. So just understand, I would suggest understanding what these words mean on the left here. And if you do, then common sense will help you with the rest. So don't try to memorize this chart or anything crazy like that. Just know what these terms actually mean and you'll know the entire chart. All right, so an air mass, when it travels over land, it's going to expel its moisture, so it's going to rain. If it travels over the ocean, it's going to become more moist. So it just depends on where it's going and where it's been, but it's going to pick up those characteristics of where it's at. All right, and then the last thing, air masses, sometimes we get something called lake effect snow. And so this occurs with the Great Lakes. It occurs with a large body. So the Great Lakes are huge. I mean, ginormous, even compared to Shasta. Shasta Lake is like Mary Lake compared to the Great Lakes. And so they kind of have their own little air masses that form over them. And it creates weather in areas that are near it. Like Chicago, for example, has a lot of this lake effect snow. So basically what happens, you've got this continental polar air mass moving over. There's evaporation occurring. And so you get these, and this is a little cumulus cloud forming. So you get these little cumulus clouds or clouds in general forming. And so then when it goes over the land, because of adiabatic cooling, it's going to release that moisture. And that moisture in the winter, especially, is released as snow. So it's called lake effect snow. And this happens often in the winter. We get this continental polar air mass moving over those lakes and creating snow. Like I said, Chicago is a great example. So Chicago kind of sits on the southern end of Lake Michigan. And so the air moves across and snows a lot in Chicago because of that. And so that occurs in large bodies. So Shasta Lake is not large enough to have this effect. Either is Whiskeytown. It has to be something very, very large. So pretty much in the US, it's just the Great Lakes that occurs on. All right, and that is it. I hope you enjoyed.